Hi everyone, welcome to today's Safety and Health webcast. NFPA 70E PPE changes affect PPE for 2018. Know the changes. Sponsored by BSD, BTTG, Arcware, and eHazard. My name is Kevin Drewley. I'm an associate editor with Safety and Health magazine, and I will be moderating today's session. Thanks for joining us. In a few minutes, we'll start the presentation, but first I want to go over some preliminary items. The views of today's speakers and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box in the lower left-hand corner of your screen and click the button for Submit Question. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speaker. For basic troubleshooting information, click the Help button located on your screen. At the end of the webcast, you will be asked to complete a brief evaluation survey. I will let you know more about that after the presentation. This webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/event. With that, let's go ahead and get started. Our speaker today will be Hugh Hoagland, Senior Managing Partner and Co-founder of eHazard. Hugh has assisted in the development of electrical and flash fire safety legislation and standards in the United States and internationally, and has been ARC testing and writing standards since 1995. He has lent his expertise to numerous training videos in more than 700 companies worldwide. Again, we thank all of you for tuning into this presentation. Hugh, whenever you're ready, go ahead and take it away.
Thanks a lot. Today we're going to look at the 70E changes and kind of focus on the PPE section. We'll focus on how other parts affect the PPE, and we'll also focus on some of the major changes in the standard overall. One of the big things that happened in this standard, they kind of brought forward the risk assessment procedure. It's a major improvement in the standard, but it does muddy waters just a bit, so you have to understand exactly what they're trying to say if you're not used to risk control versus hazard control. So one of the things that we like to get people to understand about a risk control process is any of these can be effective, any of the different parts of the control process, whether it's elimination, substitution, engineering controls, awareness, administrative controls, or PPE. It's just that some are better than others. And so it's now new, but it's not anything new, but it's mandatory in the standard now, kind of focuses the language toward risk control rather than just hazard risk assessment as in previous versions. The hazard risk also has a new section, and consideration for human error. There's an annex working around human error. One of the things we like to bring out on PPE is you want to be careful about PPE. PPE, sometimes people think, and one of the things about PPE for 70E that's different than most PPE settings. Most PPE is sort of protective. If you look at flash fire clothing, it allows 50% body burn in a very specific burn, whereas with arc flash clothing, we allow it only to cross the second degree burn. We don't allow anything to cross the third degree burn in our calculations of the ratings, but when you're using it, it's almost like a smart PPE. And I like to think about it that way because we match it to the hazard, whereas in flash fire, it's just a very generic low-level protection so that if you do get in a flash fire, the clothing doesn't increase your injury and will provide some protection. But we try to match PPE in arc flash, so it's a little different than a normal PPE. It's kind of like using something along the line in between, say, a flash fire garment and a firefighter's uniform, which is designed to totally protect them from being in a fire. At some point, a flash over may not totally protect them, but it's usually very, very protective. And arc flash is very much the same way. But you have to be careful about human error being introduced because of heat stress. I have a lot of companies that will say, well, we're just going to provide a lot of extra PPE and put on too much PPE, causing problems. We actually had a worker once a few years ago that was wearing an arc flash hood for a long period of time. They didn't pay extra to get the fans that kind of came out a little bit after that. Fans really came out big. But this person was in it for a long period of time and actually passed out and fell into the switchgear. So it didn't cause a fatality, but caused the person to get hurt. And we've also had people putting on arc flash suits that have fallen and had a lost time injury once from trying to put on the arc flash suit. So be careful about understanding your human errors and things where these can come in. And that's one of the things that can be addressed somewhat with PPE, but you definitely want to think about it that PPE doesn't become the source of a new error. Job safety planning is now a new part of the standard. Now, I think even though the term wasn't there before, this idea was there, but now it requires that it be completed by a qualified person and be documented. Now, your JSA process may already take care of this. Your electrical safety work permit may already take care of this, but it's a new version of the standard, and it's trying to increase the understanding of what a job briefing really does. A job briefing should be based on job safety planning. Another thing that's happened is they've spelled out lockout, tagout a little better to try to make it more like what's in OSHA already. They were kind of depending on OSHA before for this, but they've decided to spell it out here to make it really clear what lockout, tagout does and how you implement that in 70E. Now, one of the big things that happened was the task tables got moved and restructured, and the PPE used to be go, no go, but now it's not quite as clear because they've introduced the idea of risk assessment a little more built into the structure. In the previous version, you see at the top there was a yes, no of whether you needed arc flash PPE. Now there's a yes, no, is there a likelihood of occurrence? Now, you should probably still take that likelihood of occurrence of yes, no on arc flash PPE, but some people may not be clear that that's what the intention is. Unless you find that there's no need for arc flash PPE when there's a likelihood of occurrence, you should document that if you do find that, and there may be some cases where you do. But most cases, that should still be, yes, there's arc flash PPE needed, or no, there's not arc flash PPE needed. So what does the no likelihood of occurrence mean? NFPA just recently addressed this in the NFPA Journal because it came up pretty quickly. And Derek Viskel said a estimated likelihood of occurrence of no does not mean an arc flash event would not occur. Anyone conducting the arc flash risk assessment has to determine its circumstances. So basically what they're saying is even if it says no, which before it would have said no PPE needed, now they're saying even no doesn't mean you don't need PPE. Don't go overboard. Be careful about this. I knew somebody that was putting people in 100 cal arc flash suits for testing 120 volt common receptacles, and that's completely ridiculous. There's no real chance of arc flash that would cause you to be burned even on your hands testing a receptacle. You just need shock protection, and obviously that will provide arc flash protection at that level. But do make sure you understand what these specific things mean. Also, new big thing that happened was, and this does relate to PPE, the less than 1.2 calorie per centimeter squared section out of H.3b is gone, but they moved that whole section into mandatory language in Table 130.5G. Now, this is really important for two reasons. One is some people will say, oh, well, now I can do arc flash. If there's no real big arc flash up to 1.2, I can go ahead and do that in polyester clothing. That's not at all what the standard was trying to say. It just said anything below 1.2, we're not going to address PPE, but you still have to wear non-melting clothing underneath PPE. So functionally, there's really no change here, but some people will take this and make a mistake of putting people, say, in a power plant in non-flame resistant clothing and even letting them wear polyester when if they ever have to put on an arc flash suit, they're going to have to take off their clothing, put on something that's non-melting, or put on the arc flash suit naked. So it's not really practical, so do be careful that you don't misinterpret something. They were trying to get common street clothing that would be non-melting to not be called PPE because of some problems in union contracts and in company contracts and safety programs. They wanted to make sure that it was clear that this is clothing that would be normally worn, but you still want to make sure that it's non-melting clothing if it's going to be worn in any chance of an arc flash event. Electricians, it shouldn't be an issue. It kicks in when you talk about operators and things like that. So assess the circumstance, see if you think there's any likelihood of occurrence or enough energy that it would cause clothing ignition. I had a company that recently said, oh, we're going to rack our 4160 switchgear because it says no likelihood of occurrence in street clothing, and we're going to even allow them to wear polyester. That's ridiculous. Don't do that. Don't let anybody rack switchgear without an arc flash suit. Chance is low, but it can happen. All right. So what does this no PPE required mean? Well, the short answer would be if your risk assessment says there's no PPE, And I would say in the case of 120, 240 systems, except for three-phase 208 systems, that probably means that you don't really need any special PPE. Should you wear polyester? Probably not. Is it really a super high risk in that level setting under 1.2 calculation? Probably not. The software doesn't do a real good job of calculating the real risk at 120 to 240, except on three-phase systems. Just be really careful. Follow your hazard risk assessment. If it says 10 cals and it says no likelihood, be very careful. If it says half a cal and it says no likelihood, maybe you'll be okay. But you need to make that decision as a company and not just let it be willy-nilly out in the field. So I've got a little more detail here that I think will be helpful, but I'm not going to go into a ton of detail on that unless we get a question around it. Arc flash gloves. There is an arc flash test method for gloves. It doesn't require rubber gloves or leather gloves to be tested, and most companies have tested them. You can get that information from your manufacturer. Rubber gloves will ignite, but honestly, it's rarely ever happened. I mean, one or two that I know in my whole career, and I've done about 160, or been involved in 160, 170 accident investigations as a consultant on one part or another, and I've done about 25 or 30 in-depth investigations in the course of my career. So I've seen a lot of this, and I've talked to a lot of people in this situation. So I want people to wear arc flash gloves. I want them to wear rubber gloves and leather protectors or some kind of a protector glove. We do have a new standard that's proposed on that right now, but it's not come out yet. But you need to wear a protector glove. You need to wear your shock protection, and you need to have, if you're not doing something that has a shock hazard, you can wear an arc-rated glove. Be careful. Some of them don't clearly state that they're just for something where you have no shock hazard. So do watch that. I've even seen some improperly advertised, I think. They weren't trying to confuse people, but they had some pictures that weren't quite representative of what you should be using them for. A big change in the standard, and I don't think a lot of people are going to be concerned about this. I was concerned about it. I opposed it, but honestly, the committee has a good reasoning for doing this. It makes the standard a little bit more international. So here's the reasoning. PPE now, the arc flash standards were U.S. standards, and they've been moved to an appendix, or they've been moved to notes, informational notes, which means they're non-mandatory, but you have to conform with something. Now it says conform with applicable state, federal, and local standards. Well, OSHA says to comply for arc flash, at least in 269, you need 1506. So it really won't effectively change anything in the U.S., but it could be used in other places to use IEC standards, other standards that are perfectly acceptable for arc flash. We're actively involved in those standards committees, and we want to make sure it really protects people. So no big difference, but do realize that it says they're non-mandatory. Now, something in NFPA that is non-mandatory doesn't mean that there's not a requirement. It just means that's one way to meet it, but if you find another way to meet it, it's perfectly acceptable. The H.4 new conformity assessment language. Now, remember, the annexes are non-mandatory, but there is mandatory language on conformity assessment in 130.7 C14B. B says that we can self-declare, which is what almost all PPE in the U.S. today is self-declared. The testing is happening. The companies are certifying it themselves. They don't use a third-party certifier because there's really not a third-party certifier that's been involved in this committee for very long. They do allow second level, which is I'm an ISO 9001 or a qualified registered quality management system, which would be ISO 9001 would be one option of that. And then I also do accredited laboratory testing, which 17025, like our lab, would be accredited for that. And then the third level is full-blown third-party certification. Now, SEI or UL are common in the U.S., but neither one of them have many things they've ever certified, and they don't typically do this type of testing. You can have them do this testing, but it's very, very rare. We're hoping to see that improve in the future, and SEI is part of ASTM now. UL is a for-profit certification body. There's lots of opportunity for improvement in this, but the reality is we don't have a lot of failing things. I've rarely found anything in the U.S. market that fails. We don't have a big problem, but people wanted to improve this level and make sure that people were testing at least every 5 years, which the self-certification in ANSI 125 recurs, and we'll talk about that here in just a second. And then there's some new specific requirements around marking that's new, and those are mostly in 1506, but you want to make sure your PPE meets that requirement. Now, ANSI 125, which is mentioned in H.3 or H.4, is a conformity assessment. It has 3 different levels. The big thing this adds, and I think it's actually good, it adds the opportunity or the requirement to test every 5 years. Now, that is a requirement in ANSI 125, but 70E didn't require 125. They just listed as one option. There's also an ASTM standard. It's brand new. It's ASTM 3050. It's a 17. It's a -17, and we were on this committee, worked on this committee. But it now has some other opportunities. So there's some opportunity there. If you want a higher level of certification, you can use, I would say, either one of those, even though one is listed in the back. This one came out during the process, so it didn't get listed. I think it came out after the voting was done. But either one of them are very similar, and they can give you guidelines on conformity assessment. The next thing is there's some other changes. There's auditing has been clarified a little bit. Use for, I recommend that you audit your PPE periodically to make sure it's in compliance. We find when we do electrical safety audits through eHazard out in the field, we find PPE that just doesn't meet the standard, PPE that's improperly labeled, PPE that's the wrong pick. They pick something that's flame resistant, but it's actually a melting thing and doesn't meet the ASTM standards that are the proper standards. So being very careful that you're auditing the PPE periodically and auditing what you're recommending, auditing what your stores are buying. I've had more than one accident where stores started buying something that was cheaper, thinking it was an equivalent. They substituted it because it was a lower price and found that it actually wasn't right, and somebody wound up getting hurt. That doesn't happen very often. Most of the time your specifications are clear enough, but if you don't think things really clear in accordance with the standards, you can wind up with a problem like that. And they also added some definitions which are important, but not anything that really affects PPE. We recommend that you use a continuous cycle. This is kind of a dimming model, but we've filled in some eHazard letters on it. So we want to envision, get our end goal. We want to execute. We want a written program. We want written of what our PPE is going to be, how we're going to use it, written, very clear for the worker, very clear for the contractor coming in. That's another problem sometimes. People have contractors come in, and they don't actually do electrical work. They hire a contractor for it. Electrical contractors tend to be really good. Sometimes manufacturers contractors that work on equipment don't have the right safety training. So be careful about all those contractors. Write your electrical safety program into your contractor requirements and make sure that you're following up. Even here at our office, we have a laboratory that has two different three-phase systems. In that setting, I've specifically required 70E for electrical contractors, and one time had to go through 3 before I found one that actually was following 70E. And we made them follow 70 while they were here, but we tried to switch to find someone, and we've got someone now, but it's really tough to do sometimes unless you get a union contractor, and we had a difficult time getting the unions to deal with our small plant, so our small office. But definitely try to make sure you get good contractors, and obviously, like I said, the union contractors that are electrical unions do an excellent job, and some others do too, but make sure you get a qualified contractor. Evaluate the program with auditing. Audit the program, audit your documentation, audit your PPE, make sure everything is meeting the standard, and make sure you're getting what you think you're getting. And then last, evolve the program. When you read an article and you find some new information, look at that new information, evaluate that information, find out what they're selling, which is always a problem with reading articles, and then go back and dig in and see if there's some need for that. It's really important to have experts when you need them, but most of the time you can learn about this stuff on your own. It's really important to keep your program up to date. We recommend a comprehensive approach for your electrical safety program, your risk analysis, your risk assessment, your training, your investigations, your audits, and your maintenance. Investigations got added to the standard this time. So we're going to talk about how to improve each one of these sections, just rough, making sure you have a written electrical safety program. A lot of people have PPE that have labels, but they really don't have a good, solid written electrical safety program. We have a program that we offer to people. We have a class on how to write programs, but we offer the program documents that start off and give you something that they always have to be customized for your sites to make sure you're meeting the full OSHA requirements. But having all of the aspects of your program in place will make sure in PPE, you've got to have the right PPE being ordered, you got to have the right PPE being worn, and it being worn in the proper way. We did a paper one time on 40 different accidents with 50 people involved, and we found the only people who ever got hurt, there were a couple of incidents where the energy went way over the estimated from the 70E tables. The calculations would have shown that there was a problem, but they didn't do calculations. Those couple of people got hurt. But out of that, the only people that got hurt, except for those two, and they were oil-filled 138,000 volt type systems, very unusual systems. But the only people that got hurt were the people that didn't wear all the PPE. They took off a glove. They took off a hood. They weren't wearing the shirt, the jacket, something of that nature were the people that got hurt. So the PPE works, but you have to make sure it's worn and it's worn properly. And in some cases we found it was a human performance issue where they were putting too much PPE on and the workers knew that it was too much and they just didn't wear it all the time. And one time they didn't have it on when they needed to. So make sure your program is robust and your program is evaluated regularly. Use a multidisciplinary team. Make sure you're rolling out the program adequately, auditing it, and make sure you're basing it on standards and updating it as standards change. Be either OSHA, the latest standards are out there. They're changing every 3 to 5 years, and so making sure you're staying on top of that. Training is required. Make sure you train on how to use the PPE. This may be done on the job or classroom, just making sure people understand how to use it. We see that as a problem from time to time. Training cycle, make sure you're auditing the training. You're making sure that you're doing spot checks. You're updating it as the programs update, and you're updating the PPE training if you change the type of PPE that you're using. Also, auditing is critical to your safety processes. We had a company not too long ago that decided they were going to audit. They were seeing some of their uniforms that were showing up, and they just didn't look right. They looked like they were having an extreme amount of wear. So they sent them to Arcware, the testing company, and we did some vertical flame testing, very inexpensive test, and found there were some of their uniforms that were failing. And what we found out was there was a metal contamination, which is very, very unusual. Don't get scared that your uniforms are failing, but it was a very unusual high metal content workplace with metal dust, and it was getting into the garments and not getting out satisfactorily, and it was blocking the flame resistance of that particular garment. And they were able to solve that problem, but it was a real problem. So periodically auditing, and if you ever think there's a problem, get with your manufacturer. Manufacturers, laundries, and of course independent companies are happy to help you try to make sure something is adequate and working for your people. So audit things, ask questions if something doesn't seem right, and also look at your audit cycle and make sure it's in compliance with the standard. Risk assessment, identifying those risks, looking at the risk, the real risks of electricity. We know what they are. They're arc flash, they're electric shock. There's also fire ignition. There's arc blast, which probably gets a little too much publicity, but there is arc blast, especially if the door is closed. It can blow off. Also, step potential, touch potential, and making sure that we understand all the hazards and how our PPE can help. Making sure you have arc-resistant PPE, arc-rated PPE for, actually we call it arc-tested PPE for fall protection so it doesn't catch on fire and then not work. Arc flash and shock is important. One of the things that I think gets kind of lost in this, we got a lot of publicity for arc flash, and that's great, but most people die from shock. And most people get an arc flash when they get a shock. And if you prevented the shock in the first place, some of the arc flashes would go away. I think we've pretty much eliminated the deaths from arc flash. I haven't seen an arc flash death in the last 15 years except when somebody's wearing non-flame resistant clothing. I've seen a few people get burned. It's very limited, but I have seen a few people get burned, and we were able to explain every one of those. But shock is still happening. Our fatalities have dropped by about 57% since '94. It's a fantastic job, but we can do better. Looking also at the hierarchy, making sure that we're applying the proper risk control methods. So can I eliminate it? Can I design it so that it's all covered up, it's shock-proof, it's touch-proof? There are ways to do that. Can I go in and look at substitution? Can I substitute by putting in this arc flash switchgear? It's not elimination. The hazard is still there, but you make it so that the energy goes away from the worker when the door is closed. When we operate this switchgear, the worker is not exposed because as long as the doors are closed, the energy goes up through a louver onto the roof or outside of the building into a safe area where it doesn't hurt anyone. Making sure we put in engineering controls when we can. Maybe you can rack it from a distance. Maybe you can operate it with some kind of a switch. Maybe you can cut down the energy by using some engineering controls that don't eliminate the hazard, but they reduce the hazard to a manageable way. Also making awareness, putting on arc flash labels, doing an actual study, and finding ways to reduce with engineering controls the energy, and then making your workers aware of places that there is a hazard. Then putting in administrative controls like written programs, energized work permits, and then last, PPE. Now, you can't ever substitute at this point PPE. We're still going to have PPE no matter what we do, because you have to test circuits. Even if you turn them off, they have to be tested. Until they're tested and grounded, they still have a potential for arc flash and for shock. So we want to make sure, even if we're de-energizing all the time, that we have the proper PPE in place. We want to make sure clothing is not ignitable. Now, that's a little bit of a problem in the new standard since it eliminated that below 1.2. Realize that still by law and also by 70E, you can't wear ignitable clothing at any risk of arc flash. So that could ignite clothing. And some people say, well, 1.2 can't ignite clothing. Well, 1.2 is a calculation. It's an average calculation. And depending on what's closer, if I put a non-flame resistant glove up and operate something and I get a 1.2 at 18 inches away, I've got close to 4 or 5 calories at the hand. The hand could catch on fire. We've actually had gloves catch on fire with people, not at 1.2 calculations, but in some calculations that you wouldn't really have expected it. Making sure that we wear the right stuff, things that don't ignite and continue to burn. Even cotton can burn. Making sure that we match the PPE to the hazard. We make the PPE smart. Don't go overkill. It sends the wrong message, but it also makes the person sweaty, and if you get sweaty, your protection can go down, and in most cases does go down. So don't forget specialty gear. There's things that are not ARC rated, but the standard requires that we consider them. We're getting more and more things that can be ARC rated, but there's still things that won't be. We're not going to ARC rate SCBAs. We're probably not going to ARC rate respirators, but you can consider them, think about them, maybe cover them up with a face shield. There's ways to prevent them from becoming a problem. There's some PPE, if you can get PPE that matches these standards, you have ARC rated or you have PPE that's been shown to work well in electric arc. Then also, this is a particular lesson where a guy got burned because he wasn't wearing a glove. He didn't have on his insulated gloves because he was doing something that he wasn't going to be touching an electrical shock hazard, but he slipped and caused a burn. That's actually a video that we have that's on the website, and it's on YouTube. It's called Brian's Story. It's free. You can download it and read it. It doesn't sell you PPE. We don't sell PPE, but it gives you insight into Brian telling his own story that he went through wearing an arc flash shirt but didn't wear a glove and got some burns, and he had his sleeves rolled up too. So it kind of tells you that human factor story that we have to think about. Glove ratings. Gloves can be rated. We had a person get burned here. This was a non-arc rated glove there on the left, caught on fire and burned the guy's hands. Although his arc rated clothing worked, he didn't have an arc rated glove, and it was just a cut resistant glove. There are standards for testing gloves. These do not test for shock. Only a rubber insulating glove provides shock. Be very careful. The gloves that are coated on the hands do not have shock protection. They are not shock gloves. They're cut or they're arc rated gloves, but they're for operating. They're not for using for shock protection. Only a rubber insulating glove with a proper protector can be used for shock protection. Just be aware of that. Making sure the underwear doesn't melt, and I won't go into a lot of detail on that. Cotton can ignite. Wool and silk are harder to ignite, but they don't melt. None of these three melt. Just make sure they're protected from ignition when you're wearing them underneath. High visibility clothing, we still have a problem with rainwear. We still have a problem with high visibility vests, saying they're FR, making all kinds of claims of self-extinguishing and things like that. They're typically self-extinguishing in a Bic lighter test. It's useless for arc. It's useless for flash fire. If you're standing around a heater, it might be less hazardous than something else, but be very careful about making sure if you have it exposed to an arc flash or exposed to a flash fire that it actually meets the real standard. The categories are not called HRCs anymore. Now, don't throw away any clothing that says HRC in it because the levels are the same, the testing is the same, the term's gone. Companies will still label things as HRC. Some companies, I like the term ARC because I think it's clear. Other companies are using the term CAT 1, 2, 3, and 4. Any of those are acceptable because the standard doesn't tell you to label it with the PPE levels. These PPE levels that are called PPE categories are based on the tables only, but those numbers could be used with your PPE levels that you set in your standard program. Don't get too wound up about that. Some of the idealists prefer to say, "Oh, you can't use the categories unless you don't do a study." Well, that's true technically, but you can use the category levels because those category levels are based on the minimum test level. So think about it. Make sure you're applying this correctly. Most companies use 2-4 scenario, very common and perfectly acceptable in most settings. You just need to make sure you're matching it to your study. Again, the below 1.2 is gone, but that doesn't mean that you shouldn't have to wear non-melting clothing underneath. It's still required, non-melting underneath. It's just there's no PPE requirements for anything under 1.2. But be totally sure that you make sure you understand the distance. The distance is typically 18 inches. Anything that enters inside of 18 inches could ignite because it may go over the 1.2. So be careful about how you apply that. I don't think that was the intention. ARC rated, make sure you're looking at the labels. Make sure they've got the right terms in there. Ask questions. Take a picture of it, send it to me. I'm glad to tell you if something is from a legitimate company or say there is some kind of a question. We do a lot of testing. We do most of the world's ARC flash testing. We're happy to help you out with that. We don't charge a penny for a label review for an end user. Never will, never have. So always happy to help you out on something like that because we want to keep the industry honest. And frankly, we rarely have a problem with dishonesty in this industry. We have problems sometimes with misunderstandings, but we can usually get those fixed, and we talk to those manufacturers when they have a problem. ASTM F2302-08 is now withdrawn. There is a new version of that standard that's been voted on. I've literally voted on it this week. I voted positive. It will not be for arc flash clothing. If it only has 2302 in it, it's for small flame exposures, not flash fire, not arc flash, not fire, not anything we would typically consider except maybe standing around a heater or something like that. And that means that it will melt, but it may melt away from the flame. You can use 2302 for things that are arc flash, but you'll have to have 1506 in it for flash fire. You'll have to have 2112 in it. So there are applications for that. This standard was misused is why it was withdrawn. I'm not going to go into this answer, but it was about fall protection that didn't work because it caught on fire. If you use the 887 standard in 70E like this one, you'll make sure that it won't catch on fire up to 40 cals in the test. When they're a little older, they might have a little problem, but not too bad. Melting rainwear, avoid it. 2302 is not a standard yet. May come back in. Make sure you tuck, button, and roll. Roll your shirt sleeves down, button up the shirt as high as you can, tuck in your shirt sleeve because you can't ignite the clothing underneath. So making sure that we're actually protecting people. Arc blast. This is a part of a paper that we did, and we just recently did another paper. We blew up about 20, 30 different times in this box. We have, in this case, you can see that's a foam mannequin. It's very lightweight. We put a 250-pound mannequin in front of it this time. We can knock that 250-pound mannequin down. Will it kill him? Probably not. We did measure the actual force in newtons. We're going to compare that in this paper. It's coming up at the Electrical Safety Workshop. I have no financial interest in the Electrical Safety Workshop at all. It's part of IEEE. It's an excellent resource. I recommend everybody go to it. It's coming up in 2018. I think it's in Fort Worth, Texas this year. Been on that committee for many years, the Electrical Safety Committee. It's a not-for-profit like the Safety and Health, which I will endorse. Love Safety and Health. They do an excellent job. And just making sure that you get out, learn about the new stuff. We're learning more and more about arc blast and trying to get toward being able to estimate it. When the door's on, the door can blow off. Stand to the side. When the door's open, the blast is substantially reduced to the point where it may not even be anything more than knocking you backward. And we do have video to show what happens, and we'll show that at that Electrical Safety Workshop. Incident investigations. Make sure you include an expert if you're going to spend a bunch of money based on the incident investigation. We recently had a company that had a shirt that got some holes in it. It burned. It arced on the inside. Did not catch a T-shirt on fire, but they were worried that it might have. And a clothing company said, "Oh, ours wouldn't do that. Ours doesn't do that in an arc. It's because theirs is this whatever material they were deciding they wanted to cut down that week." The competitor, obviously. So we took their shirt. the competitor's shirt, and even another shirt, and actually two more shirts, and we put them all in this exact same scenario that worker was put in, and they all did exactly the same thing. They arced on the inside because this person got in what's called a tracking arc. It was 25,000 volts. It went across the worker's body underneath the clothing because of the electrical contact, which could have been prevented with shock protection, but the shock protection wasn't in the right place. The worker didn't think it was energized, and it was. And this company was going to replace all their clothing at a cost of about $500,000. And they called the manufacturer. The manufacturer called us. The manufacturer actually paid me to research this and saved that company $500,000. So they would have changed out a bunch of clothing that wouldn't have made any difference. So don't have knee-jerk reactions on your incident investigation. When you need it, get a forensic engineer. Get somebody to look into it, especially if you're going to spend a bunch of money thinking you're going to fix the problem. If you're not fixing the problem, you haven't really saved anything. Investigation process, this is part of a master's thesis that one of our engineers has done, and it's IEEE paper. You can find out about that investigative process and some ways to apply that to electricity and electrical investigations. Really good paper. Read the paper and read the master's thesis. Helps you really understand the investigation process. So I've finished up all the information that I have, but I hope we have a lot of questions. If you want the PDF, if you'll send an email to questions@e-hazard.com, we'll send you that, and we'll probably send it out to everybody through a quick email. We will not spam you. You'll get one email from us, and if you want to sign up for a newsletter or get information from us, please write back because we won't hear from us again. But happy to help you out. Let's ask some questions.
All right. Excellent. Great job, Hugh. Thanks for your insights and expertise. We'll get to the Q&A in a moment, but before we do, just want to remind everyone of the evaluation survey we're asking you to complete. The survey should be appearing on your screen now. Your input is important because it'll help us improve future webcasts. If you do not see the evaluation survey on the screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. Now we will get to the questions. First off, is compliance to NFPA 70E an OSHA requirement or just a recommendation?
That's a great question. 70E 2000 version, Part 1, used to have two parts. Part 1 is law, and that is all wiring requirements. Those wiring requirements got removed after that, and OSHA does not require you to follow 70E. They require you to follow the OSHA standard, and typically if you don't follow 70E, you'll get cited under the general duty clause, and then they'll use 70E as an abatement. Because if somebody gets shocked, if somebody gets arc flashed, you did not follow proper hazard analysis, and 70E is one method of following the proper hazard analysis of OSHA. Now, OSHA has given a letter of interpretation that says that if you followed 70E, you would not be citable. So if you follow 70E, you've met OSHA, but if you didn't follow 70E and you found another way to accomplish what OSHA wants, you're in compliance with OSHA. But I'll tell you, I have very few companies that don't follow most of 70E that will consistently comply with OSHA. It's just that electrical accidents don't happen very often. When they do, they're catastrophic. So 70E is your best practice in the industry.
All right. Next question. What are your feelings about the automatic voltage testers to eliminate PPE and manual testers?
Well, there's a new thing in the 70E standard about automatic voltage testers. I like the idea. OSHA has some reservations about it. They haven't officially come out and said, yes, you can use them and not use voltage testing. If I'm going to touch a circuit, I want to use a meter that I can test the circuit, test the meter, test the circuit again, and make sure it's actually dead. So if I'm going to touch it, I don't like them, but that's my personal opinion. If it's something I'm not going to touch and I'm just verifying the absence of voltage to do racking the breaker, it's a really good idea. And but I still wouldn't say, oh, well, now I don't have to wear any PPE. The only time you don't have to wear PPE is when you've isolated and grounded, if necessary, that particular circuit, and that's OSHA law. But I love the devices. I think that they may get to the point where they would be approved by OSHA, and 70E has now given somewhat of an endorsement for them, but you still want to make sure you're following the OSHA standard. A great new technology, and I think seriously that it may be there someday completely. And some of them are starting to have, they're totally fail-safe from what I'm understanding, but not every device is fail-safe, so it may give you a false negative.
All right. ACGIH under thermal stress provides a clothing adjustment factor for some clothing. Does arc flash protection identify a clothing adjustment factor that needs to be added to the wet bulb globe temperature? If so, what is that
Yeah,
factor?
we don't have that factor. I would use the factors that you get from a CLO factor. I believe they use for the firefighters turnout gear. Typically, there is not that kind of factor yet. The DOE, if you go to efcog.org, they've done some work on this in the Department of Energy, and they published that work. FCOG is a safety group of the DOE that provides, they basically publish anything they do. So there was a paper on that on the FCOG site, and I think some of the DOE sites are actually using that. So I'd get in touch with some of them to get some ideas, because heat stress can be an issue, and also oxygen availability inside the hoods. We find that some people will pass out, especially if they have emphysema, if they're smokers. I've had a couple of people that have emphysema or were smokers, and they passed out after about 15 minutes in a hood. The oxygen does drop down, just like it would in a respirator even. The oxygen drop down inside of a hood over time. Using the hood fans probably solves this problem, or some of the lift front hoods, you can raise them up periodically, make sure the oxygen gets back in there. But all those factors have to be taken into consideration, but I don't think there's really anybody that's got a stress factor that they've given for those yet.
Next question is asking for the difference between PPE Category 1 and 2 heavy-duty leather gloves and Category 3 and 4 arc-rated gloves that are listed on Table 130.7C16. And
that's a good question. Yeah, well, typically, heavy-duty leather gloves get somewhere. OSHA now has said in 269, the new standard came out in 2014, that heavy-duty leather gloves get up to 14 cals. And that's probably true in most cases. I found a few that were not. I found a few, did a deer glove for a utility once that was about 8 cals. It was over 8 cals, but just barely. But OSHA's kind of said it's good up to 14 cals. 70E says you need, if you're wearing rubber gloves and leather protectors, which is the standard shock, I got a shock exposure, I got to wear rubber gloves, leather protectors. 70E and OSHA says you're good. Don't worry about it. And our experience is that's almost totally true. Couple of instances, very rare that you're ever going to get any burns with that on. I know of 2. So that's really rare. Rubber gloves, leather protectors, no issues. It's when you're not wearing rubber gloves and you're doing something that doesn't have a shock hazard, then you want to wear an arc-rated glove. And I would say at whatever level. If you're wearing a leather glove, basically 70E says it's good up to level 2, which is 8 calories. Anything beyond that, at level 3, it has to be arc-rated. So you want to match it to the hazard, but think about it. Your hands are a little closer, so be careful about going too low. But frankly, you don't see many people with hands burned unless they're unprotected or unless they have ignitable gloves.
Could you please clarify how often does the PPE need to be inspected, and who would be recommended to do that?
Wow, that is a great question. You know, I've seen probably 2 failures of PPE in my career. That actually failed if we took them to an ARC test. And those 2 were basically laundered. It was in a situation where either they were horribly laundered by an industrial laundry in the case of one, and the other one, it was not laundered adequately because of the metal contamination in it. That's the only time I've ever seen garments fail. It's really rare. I would recommend that you look at ASTM 1449. It gives you a list of things to look for a home launderer. Or you can use the industrial laundering. The industrial launderers have their own procedures, and they're extremely good. I've never, like I said, one time I saw a failure in a laundry. It was not in the U.S. The laundry was relatively new to FR Clothing. They made a mistake and didn't realize it. But fortunately, the end user said, hey, whoa, the arms are falling off, and our Navy uniforms have now turned pink. So that's a really good sign that there's something wrong, and they got somebody involved real quickly. I got involved real quickly, got them straight to their manufacturer. Manufacturer helped solve the problem. But I would inspect it daily, make sure you don't have holes in it, things like that. That's the requirements. Typically, a good manufacturer will have recommendations for things to look for, but because something's a little bit worn doesn't mean it's not ARC rated anymore. It might have a slightly lower protection value, but most of your protection comes from the clothing not igniting. So don't get too wound up about inspecting ARC rated clothing. Now, in terms of rubber gloves, leather protectors, there's a little more concern about inspecting them correctly, and the manufacturers will give you lots of good guidelines on those.
When do the changes for 2018 become effective?
They actually became effective 15 days after the publication, which was in September, so they're already effective. 2018, most people kick it in the next time they do their training. The standard comes out every 3 years. The standard requires you to train every 3 years, so that's basically how it works. So when you get 2018 and decide to switch to it, I would switch to it because they're now effective. But again, it's voluntary compliance versus mandatory OSHA compliance. There's no big changes in 2018 that if you had a program that was in compliance in 2015 that will dramatically mean, oh no, we've got to do something different. So don't be too concerned about that.
Are shock and arc flash risk assessments supposed to be done on all electrical systems?
Shock and arc flash risk assessments are required every time you do electrical work by 70E, and they're also required by OSHA. Does that mean I have to have an engineering study, a full engineering study? No, that's not the intention. The intention is that I look at the hazard level based on some objective criteria. It can be an engineering study, which is excellent. We do those. Some people go in and look at the 70E table and on a ad hoc basis decide what PPE to wear based on their knowledge of the engineering. So they have to know about breaker clearing times, fault currents, things like that, which is a basic fault current study, and then use the 70E tables. That's perfectly acceptable, or putting on labels. More and more people are putting on labels because that's required by the National Electric Code, but many states are on old versions of the code that didn't require it. It started being required in 2002, and it's been updated in the last few years. 70E has very specific requirements for the labels for arc flash, and you will find OSHA people will cite you for not following the National Electric Code, or they'll use it as part of their abatement, especially if there's any kind of an arc flash issue.
The NFPA standard requires that an arc hazard assessment is completed if the parameters for the maximum short circuit available fault clearing time and working distance are not known. What are your thoughts on having an arc hazard assessment completed?
Yeah, the paper we did showed that if you use the 70E tables and just ignored the footnotes, most of the time you're okay. But I will tell you that there are times you will not be okay. I recommend everybody to get some kind of an expert in electrical engineering to do an assessment for you if you don't have the in-house capabilities. Get someone to come out, look at the maximum fault current clearing time, look at the upstream breakers, how quickly they'll clear, and make sure you actually meet the 70E requirements before you start using the table. That's the best case. Will it kill anybody? Maybe not. But I really recommend that you do that, because what you'll usually find is you got some opportunities for improving that electrical system to make it even safer. It's just good practice. It's the requirement in 70E, and I think in the long run you'll gain something from it. Do I have to have a full engineering study? If you have a large plant, you really should. If you don't have a large plant, you have a warehouse or something like that, you might just want to go out, label the equipment, use the 70E, but you're going to need a little expertise to make sure that you meet those table note requirements.
Safety glasses should not have metal parts, correct?
I'm sorry?
They're asking that, or just verifying that safety glasses should not have metal parts. Well,
70E says no. We actually just wrote an article on this, and it literally went out in our newsletter yesterday. OSHA says if you have metal parts on safety glasses, they have to be suspended by something that's non a dielectric, so it can't be a chain, and you should cover them up with something that's dielectric like goggles or a face shield. But 70E didn't agree with that. 70E decided you don't have metal parts. Now, if I've got a small metal screw, which almost every safety glass will have, am I out of compliance? No, because a small metal screw that goes in glasses can't really fall in many electrical parts, or any that I know of, and cause an arc flash. It's not big enough to go across and cause to break down the air and cause an arc flash. But the best practice is to use dielectric frames.
This one pertains to underclothing. Is there a minimum rating for electricians to wear as underclothing? What about long sleeves? And what about wearing balaclava to protect your neck and face?
Yeah, I'm a big fan of balaclavas. We've seen some neck burns. We've seen people that were, used their reading glasses that raised their face shield up and got burned up on their face. Lanny Floyd at the Electrical Safety Workshop told me about that accident, and that makes perfect sense. I think the balaclava is just something to look into, even when it's not required. It's just a good practice. If you're doing over 1.2 and you got calculations, you're wearing a balaclava anyway, so I just recommend to do that. Get a lightweight one if you have a low level, so it's not uncomfortable. On short sleeves and undergarments, it's a trade-off. You want people not to sweat. Sweating makes ARC ratings go down, at least in some of our testing. It's kind of iffy, depending. It's weird. It depends on color and probably even fabric types. Some do more than others. Some of the materials don't have as much of a drop for sweat, and we got an article coming out on that really soon. But there's lots of details that you need to know. I recommend you make people comfortable. I like arc flash T-shirts for anyone who's going to be working over, say, 20 cals, because you're going to blow open the outer shell of the shirt. But typically, if you're wearing a flash suit for that, a regular cotton T-shirt works fine. It's rarely going to be a problem. Match your overall PPE to the hazard. If you're wearing long sleeves, it's because you've got less, you're counting on that second layer. Well, that second layer, if you're counting on it, needs to be ARC rating. That's a requirement in the standard.
What is the tenant obligation for labeling electrical panels in typical warehouse settings, such as 120, 440V?
Yeah, 440 is where your real problem from an arc flash comes in. 120 is a shock hazard. By the National Electric Code, it should be labeled warning shock hazard. If you calculate there's an arc flash hazard there, or if there is an arc flash hazard there, you'd want to put the level, or you'd want to put your PPE requirements as a company. On your 440, I guarantee you have an arc flash hazard. I've seen very few 440 systems that did not have an arc flash hazard, so you would want to do some kind of an engineering study or use the 70E tables, and you can label them according to the tables as long as you meet the engineering requirements of those tables. And those labels are you can literally get a stick-on label that you can do. It doesn't have to be something that you custom print. There are labels that say level 1, 2, 3, 4 if you're using the tables, or if you're doing an engineering study, your engineering group will either print you out labels or make labels for you to print.
How often should arc flash coveralls be replaced if they're dry cleaned twice a month?
Wow, it depends on the material. If you're dry cleaning them, you may never have to replace them. If you ever have a question, get an audit done. We audit garments. The fabric manufacturers will audit garments. It is a destructive test to do a vertical flame, but dry cleaning typically doesn't harm any of the flame-resistant treatments or the flame-resistant materials that are inherently flame-resistant. So dry cleaning is about the easiest you can be on every flame-resistant material I know. So I don't know that you'd ever wear them out. I recommend look at about 10 years. If you haven't worn them out in 10 years, you may want to look at replacement. That's what the firefighters do, and there are some materials that are affected by UV radiation and stuff that make them weaker, but doesn't make them not flame-resistant.
Does JHA documentation need to identify electrical qualifications of the person performing work?
If you want to meet the full requirements of the electrical safety or of the electrical safe work practice, the energized work permit, and you're going to use your JSI for energized work permit, you need to make sure that the person doing the job is qualified. Now, whether that has to be printed on there, you could print the electrician level 1, 2 if you have that. If you just have all electricians or one category, if you have multi-skilled maintenance techs, the individual needs to be qualified. It doesn't matter what the JSA says if they're not qualified. But some companies do that. They'll actually have the person sign off and that they're qualified to do this work. But other companies they pass out the JSA only to someone who's qualified. Depends on how you manage that. But if the person doing the job is not qualified, you're not in compliance with OSHA and you're not in compliance with 70E, no matter what your JSA says.
Sticking with JSA, if you have arc flash labels on equipment, are you required to put the calorie ratings on the JSA?
Oh, that's a good question. The JSA is really your internal program. So if your JSA says check the equipment for the arc flash label and follow the label with your PPE selection, then I personally think that that's documented. So I think you meet the requirements.
Are there expiration dates for ARC/Flash PPE, such as 40 cal suits?
No, none that I know of. The only exception for that would be the face piece. Face pieces typically are good for 2 to 5 years. Do an inspection. I think we've got an article on our blog about that. If you pop us a quick email at questions@e-hazard.com, that's questions@e-hazard.com. I'll send you a link to that article, but you can also Google it on the blog. There's a little Google search thing on our blog, and you can search it. We have an article on that to go into more detail on it.
How often does a facility need to perform an ARC/Flash study?
You don't need to perform a study but once, but you need to keep it up to date. Every 5 years, you should go back according to 70E standard and evaluate your study to make sure it's up to date. What we find with most companies is if they're a larger company, there's enough changes in 5 years that they should have updated the study long before that. If you have a warehouse type setting that you added a switch and put in another light, that's not really going to change your ARC/Flash study at all. So just evaluate it every 5 years or anytime you make a major equipment change. If you change breaker settings, if you change fuse types that you're using, if you change transformer sizes, if the utility changes the transformer that feeds your building, it will affect your ARC/Flash study. So make sure that you're actually looking at that. When you're adding new big equipment, any three-phase equipment is going to require a refreshing of your ARC/Flash study, if not a redoing. But typically once you've done these in the softwares that are available out there, some great software now, CAD/CAM type software, you can go in and just add this new section, either with your electrical engineering firm. We do this. Make sure your engineering firm gives you the digital files from the ARC/Flash study. If they just give you a printout or a PDF, you can't update it yourself, and if they go out of business, and we've had this happen several times, you're going to wind up redoing the study. So make sure that you get those digital files, keep them on file, and then either keep them up to date in-house or have someone keep them up to date when you make major equipment changes.
What is the trigger to perform a formal job plan?
Anything that is going to be a energized work. You're required to do an energized work permit, but job planning is required for every single electrical task, and that's according to 70E. I kind of felt like documenting job planning went a little too far for voltage testing. There may be a difference of opinion on whether it does cover voltage testing. It's not covered by the electrical safety the energized work permit. You don't have to have an energized work permit for doing voltage testing, or even de-energizing would require job planning. The documentation part went a little too far for me for some jobs, in my opinion, but the documentation just has to be there until the job's finished. So if you're just jotting down what we're doing and why we're doing it in a notepad and you're throwing it away when the job's done, if nobody gets hurt, then you've probably met the requirements. You'll only be asked for it if somebody gets hurt.
What's your definition of a qualified person?
Well, it's the OSHA definition. Have you been trained to recognize and avoid the hazards of electricity in that work setting? Do you know the equipment and the construction equipment well enough that you know what can go wrong and you know how to protect yourself in case something goes wrong? Now, that may very well be an operator just knowing that I don't open up the breaker and stick a wrench in there, but it may be as detailed as an electrician who understands how to take the thing apart and put it back together. So it depends on what task you're doing as to what makes you qualified. But if you don't know what PPE to wear, if you don't know what parts are energized or de-energized or how to avoid those parts at least, then you're not qualified for that job.
All right, I think we've got time for one final question, and that is, why is hearing protection required up to 1.2 cal? The noise hazard seems very minimal, and compliance is difficult to enforce with employees who don't believe the hazard actually exists.
Yeah, well, even 1.2 cals, from 1.2 cals up, you've got a blast. If you've got high fault current, I wish we had a better way to know. You don't need hearing protection on 120. You're never going to get enough of a blast to affect your hearing. It's really a three-phase issue. That would be an excellent submission to NFPA 70E to say, hey, can we put some kind of a limit that's not calories, because blast is not related to calories. It's indirectly related. It's related to fault current, and it's related typically to a three-phase system to get enough to do any hearing damage. So look at that, put it as part of your risk assessment, get some expert advice, and you may be able to get rid of it in some of your work settings. But if you really have something above 1.2, you do have a potential of having some hearing damage.
Okay, well, thank you. Unfortunately, we have run out of time. I'm sorry we didn't get to everyone's questions, but all of today's unanswered questions will be forwarded on to our speaker. And to that end, had seen a couple of questions in the box just to verify from the beginning that this recording will be available online at safetyandhealthmagazine.com/event. Once again, hope you take the time to fill out the evaluation survey on your screen and give us your feedback. And that ends today's Safety and Health Magazine webcast. I'd like to thank Hugh Hoagland, everyone with our sponsors, and all of you who listened in today. Thanks. Have a great day.